Very good morning, students. Let us see uniform circular motion and centripetal force. Now here, see in this figure, an object at position A moves to position B in some small time interval t. Later, it moves from B to C in the same interval of time t. Also, from C to D, it moves in the same interval of time t. That means here time interval is equal. Then what happens if distance covered AB is x meter, BC is x meter, and BC is also x meter? That means in each case there is equal distance traveled by an object in equal interval of time. AB ची स्पीड आपण फाइंड करायचा प्रयत्न केला x अपॉन टी, BC ची x अपॉन टी, DC ची पण x अपॉन टी. याचा अर्थ काय आहे? द ऑब्जेक्ट इज मूव्हिंग विथ अ कॉन्स्टंट स्पीड और कॉन्स्टंट मोशन. दिस इज नथिंग बट यूनिफॉर्म मोशन. Then what is uniform circular motion? Uniform circular motion, in short, it is written as UCM. See once again. Suppose object is at A initially reaches to B in time t and covers distance equal to x meter. Now from B to C it covers distance x meter in time t. From C to D it covers distance x meter in time t. That means in each equal interval of time the object is moving equal distance. That means it is in the uniform motion. Now, why we call this motion as uniform circular motion? Basically, object is moving along the circumference of the circular path. Therefore, this is circular motion. Hence, we define uniform circular motion. The circular motion of an object in which object covers equal distance in equal interval of time. This is known as uniform circular motion. The circular motion of an object in which object covers equal distance in equal interval of time. म्हणजे इक्वल इंटरवल मध्ये जर इक्वल डिस्टन्स ऑब्जेक्ट कव्हर करत असेल तर त्याला आपण काय म्हणतो? युनिफॉर्म सर्क्युलर मोशन. नाउ सी हियर, ऑब्जेक्ट इज मूव्हिंग फ्रॉम A to B, B to C, C to D. At each moment, see the direction of velocity. It is tangential, but it is changing at each and every moment. Consider any position of the particle. Direction here it is changed. That means at each and every moment, the direction of particle or object is being changed. That means the particle is under acceleration. युनिफॉर्म सर्क्युलर मोशन असेल किंवा कुठलीही सर्क्युलर मोशन असेल त्यामध्ये पार्टिकल हा नेहमी काय करत असतो? आपली पोझिशन तर चेंज करतो विथ रिस्पेक्ट टू टाइम युनिफॉर्मली, बट इट इज चेंजिंग डायरेक्शन. म्हणजे त्यावेळेला हा ऍक्सेलरेशन मध्ये येत असतो. मूव्हिंग ऑब्जेक्ट आहे, ऍक्सेलरेशन आहे. दॅट मीन्स देर इज अ पर्टिक्युलर टाइप ऑफ फोर्स प्रोड्यूस्ड or force is exerted on the object. Now we have seen in the previous example when we tied a stone to the rope and whirled it into air, we experienced the tension in the string which was directed towards the center or our pinch or hand. That means there is a force directed towards the center of the circular path. This force, which is directed towards the center of the circular path along the radius, that is the centripetal force. Now here, while moving object from one position to another position along the circular path, object is experiencing inward pull. This inward pull or tension, that is nothing but the centripetal force which is experienced by that object. Then centripetal force is defined as the force experienced by moving object along the circular path, which is directed towards the center of the circular path and along the radius, which is denoted by F or FCP, and its magnitude is equal to mv square by r, where m is mass of an object, v is the velocity of object, r is the radius of the circular path. The of magnitude of centripetal force is given by mv square by r. As this is the force, it is measured in Newton. Now let us see another concept, inverse square law. While explaining this concept of uniform circular motion and centripetal force, Newton observed that the force which is produced or which is experienced by the object moving along the circumference of the circular path towards the center along the radius, it has magnitude mv square upon r, but he again calculated this force. He used the Kepler's third law. That means he observed that there are few constant things, and finally he concluded that the force or the centripetal force is inversely proportional to square of the radius of the circular path, or f is proportional to 1 upon r square. That means this proportionality explains f is proportional to inverse of r square. Inverse of r square. Therefore, Newton named this as the inverse square law. Newton named this as inverse square law. Now let us see. According to Newton, the centripetal force or Cp is inversely proportional to the square of radius of circular path. Now see, f is equal to mv square upon r. This is the mathematical expression or equation which includes the centripetal force, and here m is mass of the object, v is velocity of the object, r is radius of centripetal force. We know that this velocity is equal to distance upon time. Here object is performing circular motion. Then distance covered in unit time, or here in one revolution, it is 2 pi r. Therefore, V is equal to 2 pi r upon T. So, V square equal to 2 pi r upon T whole square is equal to 4 pi square r square upon T square. Let us put this value of V square, put this value of V square in the expression F is equal to mv square by r. We will have F is equal to m into, instead of V square we are putting 4 pi square r square upon this r and t square. You will see here it is r and it is r square. R will get cancelled and one of the r from the square will be cancelled. We have 4m pi square into r upon t square. 4m pi square into r upon t square. Now we will multiply in the numerator and denominator by r square. We will multiply in the numerator and denominator by r square. Therefore, F becomes 4m pi square into r square upon t square into 1 upon r square. See here, it will become r cube upon t square. 4m pi square r cube upon t square into 1 upon r square. You know Kepler's third law? Kepler's third law. Its mathematical expression is t square is proportional to r cube, or t square upon r cube is equal to constant. As t square upon r cube is constant, its reciprocal is also constant. T square upon r cube is constant, that means r cube upon t square is also constant. Implies that r cube upon t square is also equal to k. Now here we will write k for r cube upon t square. This is first thing. Now second thing, 4 is a constant number. M, mass of the object is constant. Pi square, value of pi square is 10 approximately. That means this part is also constant. In all, we will write this as constant. F is equal to k upon r square. F is equal to k upon r square. Remove the proportionality constant. We will have the relation F is proportional to 1 upon r square. F is proportional to 1 upon r square, or Fr square is equal to constant. It indicates that F is inversely proportional to the square of radius. Square of radius. It implies that there is inverse relation between centripetal force and the radius of the circular path. Therefore, Newton said that centripetal force, it is inversely proportional to square of the radius of the circular path along which the object is moving.